This video is a part of the Predicting the Products of a Chemical Reaction playlist, and this is our second video on double replacement reactions, also known as double displacement reactions. We're going to need to have the guideline for predicting products. On the left, you're going to see a green box. Those are the types of reactions that we're going to look at. Just as before, we're going to need to know our ion charges really well, the positive ion charges and the negative ion charges that come from the periodic table and the common ion table. Here's our first example. Before we take a look at how to do this example, let's look at the top right here. We have our analogy of double replacement reactions, and in this analogy we have two dancing couples. The first couple is couple A and B, and the second couple is couple C and D. And basically what happens is one of the partner swaps with the other partner. So for this example, let's say that A swaps with C. You could also say that B swapped with D. It doesn't really matter because the result, the outcome is going to be the same. So from the outcome of the swap, C and B is going to be together now, and A and D are going to be together, right? And that's basically it for a double replacement reaction. If you take a look at the left, there are two types of double replacement reactions. One is called the formation of a precipitate, which looks kind of like this. This is where you combine two liquid solutions, or aqueous solutions rather, and what's going to result is a precipitate. A precipitate is just a solid that forms when you combine two solutions together. The next type of double replacement reaction is called an acid-base neutralization reaction. And just like in the name, you need an acid and a base. You should already know that an acid has a H in the front. It produces H plus ions. Well, a base is very similar. A base will always have OH in it, which is a hydroxide ion. Okay, so anytime you have a reaction where there is an acid of an H and a base of an OH, then it is a double replacement reaction. Below we have silver nitrate reacting with barium nitride. For any replacement reaction, whether it's single replacement or double replacement, you start off by writing down the ion charges. Once you have the charges of the ions written down, you do a swap. Now here's the result of the swap. Now we simply just combine the ions to write the product, the ionic compounds that result from this. So I'm going to assume that you know how to write the ionic compound, to write the neutral compound. If you don't know how to do it, I really want you to take a look at the previous video on writing the formula of ionic compounds. Okay, but I'm going to assume that you know it at this point. So what's circled and in blue is the final products. That's the answer for this type of reaction. I'm also going to include the names of them just for practice. I do encourage you to do it. However, the point of this video isn't to write the names. I do want you to think about the names when you are doing these, just for the practice though. All right, let's go ahead and do our second example. In this example, we have carbonic acid reacting with lithium hydroxide. So this one has an acid in it. This is most likely an acid-base neutralization reaction. So our acid is carbonic acid, our base is going to be lithium hydroxide. But we're going to go ahead and proceed the same way. We're going to write the ions first. Once you have the ions written, you go ahead and do a swap. Again, you can either swap the positive with the positive, or you can swap the negative with the negative. It doesn't matter which one you do because the outcome is going to be the same. So here's the result of the swap. And now I'm going to walk you through the small thing here. So the first product is going to be Li2CO3, so that you can balance out the charges. And the second product here, we have HOH, but if you notice, there's two H's and one O, where this is where we can actually just put the two H's together, and you're gonna notice that this is just H2O. Okay, so in an acid-base reaction, we're always gonna form water as one of the products. The other product is considered a salt, and a salt is just an ionic compound. Okay, so these are the products of this reaction, and here are the names of them. Okay, let's go ahead and do our third example now. We have sodium hydroxide here reacting with hydrochloric acid, and this seems to be an acid-base reaction again. So we're going to start off again the same way. Now once you have the charges, you do a swap for the double replacement. And after you do a swap, you go ahead and combine the ions. In this case, I just want to point out again that since we have a acid-base reaction, the H plus ion and the OH minus ion, those are going to combine to form water here. All right, and there's the answer circled. We have water and sodium chloride. Let's go ahead and do our final example. We have here iron 3 bromide reacting with potassium phosphate. I'm going to go ahead and write down the ions again. Now the ions are listed. We're going to go ahead and do a swap one more time. And here's the result of the swap. We're going to go ahead and write down the results of combining these ions now. And there we are. On the next slide, we're going to have 4 examples for you to practice. I would like you to pause the video before I go over the answer, and then you can check for yourself. Do this on a piece of scratch paper, and yeah, just check your work. Okay, again, try to do this on your own. Pause the video and check your work. And here's the answers. If you check your work and you don't have the answer quite the same as mine, then how about you take a look at the ions? I'll put the ions up and their charges so that you can see where you went wrong. And here are the charges. So hopefully you can try to rebalance them so that you have a neutral ionic compound. And if you still don't see why it's written the way that I wrote it, then you can always ask me for help. Okay. We're going to have a couple more of these types of problems for you to try, and I would like you to try them. Then once you submit it, I'll give you some feedback.